All right, today we're diving into a technique called RAPTOR, and trust me, it's a real game changer for anyone working with retrieval augmented generation. See, it doesn't just look at your data as some flat, boring list. Instead, it builds this incredible, multi-layered tree of understanding. So, let's break down exactly how it pulls that off. So let's kick things off with a problem that I'm sure you've run into with RAG systems. What happens when your user asks a question that's just bigger than your retrieval could handle? The answer is sprinkled across maybe dozens of different documents. A simple search that just grabs a few chunks? Yeah, that's just not going to cut it. It's bound to fail. And right there, that's the fundamental challenge with retrieval, isn't it? Not all questions are created equal. You've got to be able to handle the super specific, tiny details and the huge, big picture questions. And those are two totally different beasts. So think about it like this. On one side, you've got your low-level questions. The really specific stuff, like what's the token count of this one document? Then on the other side, you have these high-level broad questions, like, hey, can you summarize the main ideas across all these documents? Now, your standard RAG system, it's usually pretty good at the first kind. But that second one, that's where things often start to fall apart. Here's a good way to picture it. Standard retrieval, like your basic k-nearest neighbor search, it's kind of like fishing with a really small net. Let's say you set your k to 3. Well, you're going to pull back the 3 most relevant chunks. Simple enough. But what if your big, high-level question needs ideas from 10, maybe even 20 different chunks? That small net of yours is going to miss the whole school of fish. You'll completely miss the bigger picture. And this right here is exactly where RAPTOR makes its entrance. It was literally designed to solve this exact problem, and it does it by building a way, way smarter, multi-layered index. Okay, so RAPTOR, it stands for, get ready for this, Recursive Abstractive Processing for Tree Organized Retrieval. Whew, but honestly, the only words you really need to remember are recursive and hierarchical, because instead of just indexing raw text like everything else, RAPTOR is all about building layers of understanding, one on top of the other. The absolute best way to get this is to picture your data as a tree. Seriously. Down at the bottom, you've got the leaves. These are your original documents, all the nitty-gritty details. Then, RAPTOR cleverly groups similar leaves together into little clusters and summarizes them. These summaries, they become the branches of your tree. And it just keeps going, building upwards, summarizing the summaries, until you're left with one final high-level summary of everything. That's the trunk of the tree. Okay, so how does it actually build this tree? The process is what we call recursive, which sounds complicated, but I promise the logic is super intuitive once you see it laid out. It's really just a simple recipe that repeats itself. Step 1, it finds similar documents and clusters them together. Step 2, it uses a large language model to write a summary for each of those clusters. And step 3, this is the really cool part. It takes those new summaries and treats them like brand new documents. And then it just repeats the whole process. It clusters the summaries, summarizes them, and keeps going and going until there's only one single top-level summary left. So what do you get at the end of all this? Well, the result is just incredibly powerful. You don't just get a final summary. No, you get an entire hierarchy of information. The paper that introduced this calls the result an abstraction hierarchy. And that is the perfect way to describe it. By building this tree, you've ended up with a structure that has information at every single level of detail, from the super specific nitty-gritty text all the way up to that 30,000-foot view summary. So at the end of the day, your final vector index has everything in it, not just one type of chunk. You've got your level 0, which is the raw document chunks, all the details. Then you have level 1, the cluster summaries. These cover the main concepts. And finally, level 2, that top-level summary, which gives you the absolute big picture. And this is maybe the most important takeaway. All of these different pieces, the leaves, the branches, the trunk, they all get indexed together in one single unified vector store. We're not talking about separate databases here. It's one big pool of information with all these different levels of abstraction, and it's all searchable at the same time. Okay, but why go through all this trouble? What's the big payoff? Well, it brings us right back to that problem we started with. How do you handle all the different kinds of questions users ask? It's actually pretty brilliant. Because everything is in that one index, the system can now find the perfect level of detail for any question you throw at it. So, if you ask something really specific and low level, the search is probably going to find a perfect match with one of those leaf chunks from the original text. But if you ask a big, broad, high-level question, it's going to be a much better semantic match for one of those branch or trunk summaries. The end result? You get way better semantic coverage across the board. And here's a huge practical win for anyone actually building this stuff. Raptor works incredibly well with really long documents. Since modern LLMs have these giant context windows now, you can just feed whole documents into the process. You don't have to spend all that time carefully pre-splitting everything into tiny little chunks. It just makes the whole workflow so much more efficient. So this all brings us to one final thought. When you think about it, Raptor isn't just retrieving data. By building all these layers of understanding, it's organizing your information into a genuine hierarchy of knowledge. And that leaves us with a really interesting question to ponder. How could building an abstraction hierarchy like this unlock the true potential of your data? Something to think about. Thanks for tuning in.